Test. Okay, hello everyone, welcome to the OneClass channel. My name is Andrew, and I'm currently doing Stats and Math at University of Toronto. And today we'll be going over some common AF mathematics questions at both the high school and college levels. And if you need some homework help or tutoring, please check out the links in the description below. So now let's start our session. Okay. Second. Okay. So our first question is asking us how many inches are in 1/4 yard. Therefore, let's copy down the question first. So, how many inches are in 1/4 yard? And whenever we come across a question that asks us to convert one unit to another unit, we always need to find out the conversion factor first. All right, so now the conversion factor for this question will be 1 yard is equal to 36 inches. Right. So if we want to find out how many inches that are in 1/4 yard, we need to multiply both sides by the conversion factor with 1/4. All right. So now it's going to be 1/4 times 1 yard is equal to 36 inches times 1/4. Right. So this becomes to 1/4 yard is equal to 36/4 inches. Right. So therefore 1/4 yard is equal to 34 divided by 4. 36 divided by 4 is just 9. So 9 inches. Therefore we can write our conclusion. Therefore there are 9 inches in 1/4 yard. So that's our final answer. And let's leave a comment. Good job. Okay. Right. So coming up, we have our second question. So it's asking us what is the derivative of, I think that's ax, right, ax, a to the exponent of x. Right. So before directly jumping into these questions, I want to mention a couple things before. So first, let's recall the property in law. Right. So remember, whenever we got the e to the exponent of x times ln a, this is also equal to e to the exponent of ln a to the exponent of x, which is going to be equal to ax. Yep. So e to the exponent of x times ln a is just equal to a to the exponent of x. And second thing is the derivative, if we have a, we have u to the exponent of n, and if we want to take the derivative of it, so derivative of it, this is going to be equal to n times u to the exponent of n minus 1. Yep, as the exponent part. Right. So by knowing these two, let's go back to our question. So we need to find the derivative of a to the exponent of x. Right. So first recall what we have about. We can represent ax by e to the exponent of x ln a. Third, the derivative of dx ax is equal to the derivative of e to the exponent of x ln a. And now let's u is equal to x ln a, which means we let u is equal to the exponent part, and we will have dx ax is equal to ddx times e to the exponent of u, and we need to apply the chain rule here. So apply the chain rule. We will have ddx ax is equal to d du time of eu times ddx x ln x. Yeah, so this part is coming from the chain rule. Thus, let's recall the d du eu. The derivative of u is just u itself, and the derivative of u to the exponent of n is n u to the exponent of n minus 1. Therefore, we have ddx ax is equal to e to the exponent of u times ln a. And now we need to do the substitution. We substituting u is equal to x ln a. So we have derivative of ax is equal to e to the exponent of x ln a times ln a. Yep. And things ax is equal to x ln a. We will have derivative of ax is equal to ax times ln a. Right. So yeah, so let's write down the conclusion for this question. Therefore, the derivative of ax is x times log a. Okay, so now let's leave a comment. Oops. Oops. Okay. Okay, so coming up, we have our next question is asking us, what is the square root of 6? Square root of 6. All right. So first, let's express 6 as a product of its prime factors. Right. So we know 2 times 3 is equal to 6, where 2 and 3 are prime numbers. Right. Therefore, we have root 2 times root 3 is equal to root 6. And, or maybe I'll just write it like in this way. Yeah, so root 6 is equal to root 2 times root 3. And we cannot further simplify it or further exact any root since we don't have a pair of same factor. So the square root of 6 is just going to be equal to square root of 6. And it's already in its own simplest radical form. I'll write this down. Already in its own simplest radical form. Right. Yeah. So for square root of 6, we just leave our answer like this. Yeah, but if we got a, let's say, square root of 81, and this is going to be equal to root 9 times root 9, which is just going to be equal to 9. So in this case, the square root of 81 is equal to 9. Yeah, so that's like a difference between these two. So let's leave a comment there. All right. So coming up, we have our next question. It's asking us, what is a straight line? So straight line is a one-dimensional object in geometry that extends on both ends to infinity. So let's write that down first. A line, oops, one-dimensional extend on both ends to infinity. And it is a line with no curves. So no curves. So if we got something like this, or something like that, that is not a straight line. And and for the one-dimensional extend on both ends to infinity, if we got a line like this, let's say 0 and 1, so this is not a straight line either. Things stopped at 0 and stopped at 1. So it's not extend both ends to infinity. Yeah. So so this part is sort of like a counterexample. And third thing, there's not just one form of straight line. So it can be long, short, vertical, like up and down, or horizontal, or even diagonal. Yeah, so let's write that down. Could be long, short, vertical, horizontal, diagonal. Right. So those are not straight line. And so something like this, that, it could be super long, and it could be like this, extremely short. Yeah, so those are lines. I mean, are straight lines. And some special kinds of straight lines include parallel and perpendicular lines. So, right. And let's start a new page. So, parallel, perpendicular, yeah. So parallel lines are just straight lines that have the same slope and they never intersect. Never cross each other, and same slope. So something like this would be a pair of parallel lines. And for perpendicular, I just are straight lines that cross each other at one point that forms 4 right angles. Okay, so cross and forms 4 right angles. So examples could be something like this. So as you can see here, it forms 4 right angles, which are 90 degrees for each. Yep. And coming up, and we want to name the lines. There are 2 ways. Okay, I'll write it down here. Name the lines. So there are 2 ways. One way is just with taking 2 points and adding a line about it. So let's say, oops, we got a line like this. So that's both sides to infinity. and there are 2 points A and B and Y. So the first way of naming it, we're just taking the 2 points and adding a line above it. Or the second way is using one lowercase letter. So for the lines we're given, we can name it either AB, or we can call it line Y. And it doesn't have to be Y. It could be L or H. Yeah, it doesn't really matter. Yeah, we can also call it LH, line H. Yeah. And right, so the last point in terms of the angle of a line. So angle of a line. Yeah. So angle of a line can be measured, and this is done by taking 1 point from the line and drawing a circle, or drawing an angle arc from the point to another point on the line. So by saying that, let's say we got 1 point here. Let's call it A, and I'm taking point A from the line and drawing an angle arc from point A to point B. So here's my point B. Yep, oops. Right, so something look like this. And the angle formed by this straight line is always equal to 180 degrees. So I'll write the conclusion here. So the angle formed by a straight line is always equal to 180 degrees. Right. Yep, I think that's all we have for this question. Right. Okay. So let's leave a comment there. Right. So next question is asking us what is the sketch of the graph of fx is equal to e to the exponent of x plus 1. Let's move it here. Right. Yeah. So first, let's say the step 1. We need to understand the transformation of it, which means, let's say we have a gx, which is equal to e to the exponent of x, and after a certain transformation, we will get our fx, which is equal to ex plus 1. So first, let's draw a sketch for EX. So we have something like this. So that's GX is equal to EX. Yep. Where it intersects y-axis at 0, 1. The coordinate is 0, 1. And it will infinitely get close to x-axis, but never cross it. Oops. X, y, and this is 0, 0. All right. And so that's the sketch for GX, and some characteristic for GX. I'll write it on here. So it's upward sloping and always lies about x-axis. Right. So always lies about axis means its y value is always going to be positive. Right. And the second characteristic is for positive values of x, the graph increases faster and infinitely. Increase faster and infinitely. Yep. So this goes to infinity. And the third thing is, like I mentioned about, it intersects a y-axis at 0, 1. And oh, I forget for the negative value of x. For negative values of x, where is this part? The graph approaches but never touches x-axis, and where x-axis is its horizontal asymptote. So that's the next point. Horizontal asymptote is x-axis. Yep. Right. Right. So by knowing this, we can do our transformation. So so as you can see, from e to the exponent of x to e to the exponent of x, and then plus 1 for the y value, which means we just shift the whole graph 1 unit upward. So let's write it on here. Shift the graph 1 unit upward. Right. So let's copy down the graph we have about. Right. So this should be, because we're moving 1 unit upward, so the original y-intersect point 0, 1 should becomes to 0, 2. So let's use blue. So from 0, 1 to 0, 2, and so it should be something look like this. So that's fx is equal to e to its exponent plus 1. Right. And yeah. And let's talk about the characteristics for fx. So characteristic for fx is equal to ex plus 1. It is quite similar to the characteristic for gx, but there are some minor change. Okay, so the first one, it is still upward sloping. Upward slopes. And still always lies above axis. And then for positive values of x, so we're talking about this part for now. It increases slower than y is equal to ex, but still goes to infinity. Right, so still goes to infinity. And next thing is for negative value of y, which is the green part. It approaches but never touches the line y is equal to 1. And remember, for gx, we never touch the x-axis, which can also be written as y is equal to 0. And now since we move the whole graph 1 unit upward, so now it will approach us but never touch the line y is equal to 1. Yep. And now y is equal to 1 is our horizontal asymptote. Right. And as we mentioned earlier, it's shaped upwards 1 unit, so the new y-intersection point should be 0, 2. 0, 2. It intersects the y-axis at 0, 2. Right. So yeah, so those are the characteristics for fx. And then now we can write our conclusion. Therefore, the graph of y is equal to ax is shown above. It is upward sloping, increase slower than y is equal to ax, but still infinitely for positive values, values of x. In the graph approaches but not touches the line y is equal to 1, which is the horizontal asymptote. And lastly, it intersects at 0, 2 on y-axis. Yep. Right. So let's just leave the fx sketch on the graph. Right. And let's draw the horizontal asymptote as well. So that's y is equal to 1. And it will approach to y is equal to 1. Oops. Yeah. I'm going to change the color. So it will infinitely approach to the pink one, which is our asymptote, but never across it or say touch it. Right. So that's all we got for this question. Let's leave a comment there. Alright, so coming up, it's asking us how to find the vertex of a quadratic function. So first, let's define what quadratic functions is. So a quadratic function is one of the form y is equal to ax squared plus bx plus c, where a, b, c are real numbers, and a is greater than 0. And so the graph of a quadratic function is a parabola, which is something look like this. So parabola So parabola look like this, and let's say that's 0, 0, and that's 1, 1, and 2, 4. So same for here, that's 0, 1, 1. I mean negative 1, 1, and negative 2, 4. So that's the graph of y is equal to x squared. So y is equal to x squared is a quadratic function whose opening is as an origin, and the origin is also the vertex of the function, and that point is a minimum because any other point go above of the of this point. Right. So in this case, let's write it on here. So the equation of y is equal to x squared is a quadratic function whose opening is at the origin, which is 0, 0, and the origin is also the vertex of the function, and the point is as a minimum. Right. So, understanding this example, let's go to our next step. So the vertex of a quadratic function. Yeah. So first write down our definition. So the vertex of quadratic function is the maximum or the minimum point of the parabola so it is also the opening point of the graph. It is also the opening point of the graph, and it is denoted by point, like coordinate, so something like xy. Yep. So it can compute it using the formula, which can be computed by using the formula, which is x, which is this part, is equal to negative b over 2a. So this is find x coordinate. Right. And therefore the value of y can be found by directly substituting the value of x to the original functions. And yeah, so let's use an example to explain that. Let's say we have a quadratic equation defined by y is equal to x squared minus 2x plus 1. Right. So in this equation, we know, let's define our ABC first. Okay. So A is equal to 1, B is equal to -2, and C is equal to 1. Right? And now we just need to substitute the values to the formula, which is given by x is equal to -b over 2a, which is equal to -2, because b is equal to -2. And for 2a is just 2 times 1, which is equal to, because -2 is just going to be 2 itself, and 2 times 1 is 2, and 2 over 2 is just 1. Right? So now we have our value for x. Now we can substitute it back to get our y. Right. So let's copy down the original function for y. So y is equal to x squared minus 2x plus 1. So x squared is just 1 squared minus 2 times x, which is just 2 times 1. 2 times 1. And then the constant part is just plus 1. Right. So this becomes 1 minus 2 plus 1, which is 2 minus 2, which gives us 0 as our answer. Therefore, we can write our conclusion. Therefore, the vertex for y is equal to x squared minus 2x plus 1 is 1, 0. Right. And also we can prove this part by looking at the graph of this function, which is something look like this. Right. So here we go 0, 1, 1, 0. Yeah. So that's y is equal to x squared minus 2x plus 1. Yeah, and you can see here the 1, 0. In this question, it is as a minimum, and it also the opening point. And yeah, so the vertex for y is equal to x squared minus 2x plus 1 is 1, 0, which is right here. Right, so that's how we find the vertex. So let's leave a comment there. Okay. So the next question is asking us how to convert 69 inches to feet. Right. So whenever we got a question asking us converting something to another thing, we always need to find our conversion factor first. So conversion factor. So we know 1 foot is equal to 12 inches. Right. So now we need to convert 69 inches into foot, which is 69 inches times our conversion factor, which is 1 foot 12 inches. And so 69 divided by 12, which is 5.75 feet. Right. So now we can write our conclusion. Therefore, 69 inches is equal to 5.75 feet. Yeah. So that's all we have for this question. And so to convert to 62. Yeah. So the answer is correct from the Janine The Tutor, but just with a little typo. Okay. Should be 69 inches instead of 62 inches. Answer is correct though. Conversion factor, and it's conversion factor, and the answer is correct. Good job. Yeah. So he only did a minor mistake of explaining why we need to, what we need to convert. So it is still correct. Right. So coming up, we have our derivative. Oh, antiderivative. Okay. So it's asking us what is the antiderivative for sine square x dx. All right. So antiderivatives also means we need to find the integral of this certain function. So first, recall some trigonometry identities. We have trig identity. Which is 1 is equal to cosine 2x times 2x plus sine 2x So we have our sine squared x is equal to, well, I think my iPad just running out of batteries, and yeah, so I think that's all the questions for today. And if you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscription button and the notification bell below. And if you'd like to submit your own questions, please read the links in the description. Remember to leave a like and a comment and share this video with your friend. And this has been Andrew from OneClass.